Good afternoon and welcome to today's webinar entitled Firestopping Engineering Judgments. My name is Anna Diaz and I will be your moderator today along with John Zalewka, who is our Senior Manager of Engagement and Programs. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We have disabled the chat feature during this session. However, questions can be sent in the Q&A section at the bottom of your window. We will gather your questions during the webinar and hold a question and answer discussion at the end. We will be reporting AIA credits for those who attend at least 75% of this live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, you can use your certificate of attendance to self-report to whichever agency you wish. In addition to your certificates, STI has partnered with Credly to provide you with a digital badge of your credentials. Digital badges can be used in email signatures, digital resumes, and shared on social media sites. And finally, a recording of today's webinar, along with your certificate of attendance, will be uploaded to our Firestop University within the next 5 business days. You can connect to our Firestop University through your Access STI dashboard, which we will tell you about at the end of today's session. Please remain with us until the end of this presentation to receive instructions on how to retrieve your certificate. And now I would like to introduce John Zalewka.
Thank you, Anna. Welcome everyone to Firestopping Engineering Judgments. I'll be presenting today. Keith Sanford, who put this presentation together, is on as a panelist. He's a little bit under the weather, so I'm filling in for him. So I'm going to do my best here. So let's get started. Engineering judgments show up on construction projects often when field conditions differ from the original intended design. And while they are unavoidable at times, upfront planning during pre-construction meetings and coordination between the trades can minimize the number of EJs required. So hopefully that's what you'll get out of today's presentation. So we have developed this STI, it's copyrighted, so please do not reproduce, redistribute, or display any material without contacting us first. As part of the AIA One Learning Unit HSW requirements, this session has also been registered with ICC, and as part of the education requirements, here are today's learning objectives. At the end of the program today, you'll be able to recognize the unique challenges of engineering judgments. You'll be able to define what elements are needed for obtaining them. You'll be able to summarize what firestopping is, generally speaking, and what third-party testing is all about. You'll be able to identify which code provisions allow for the use of EJs and how various authorities having jurisdiction interpret them. And finally, you'll be able to identify the guidelines and other key resources for obtaining them. So here's the agenda for today. First up, we're going to lay the foundation by understanding the premise of firestop systems, how they're crucial for safety and compliance in various settings. We're going to talk about engineering judgments in general. We'll show you some common applications, what they are, their vital role in firestop systems. We'll explore who's issuing EJs currently, how long they typically take, and how to obtain one. And then moving on, we'll get into what stamping of EJs means and how that dovetailed into some new oversights on engineering judgments. And then finally, we'll show you some real-life examples before finishing up with Q&A and giving you some firestop solutions about how STI can help. So let's get into this. Fire-stopping systems, they're designed to inhibit the spread of fire, hot gases, and toxic smoke, essentially by sealing openings in walls, floors, roofs, anywhere there's openings. This is going to include any penetration, things like pipes and cables, ducts, also membrane penetrations when you have maybe a breach in just one side of an assembly, like an electrical box. And of course, your different types of joints, whether that's an interior finish, gypsum wall joint, masonry joints, or at your perimeter with your curtain walls. The building codes are going to mandate that these systems undergo testing and receive ratings as an integral part of an assembly following an approved test standard that we're going to tell you about. So here we see some common examples of firestop applications. We can see a plastic pipe penetrating a gypsum wall, a curtain wall joint at that edge of slab. We see a typical header wall joint here where the gypsum board meets the underside of a steel fluted deck. And these firestop systems use a variety of specially formulated, independently tested, fire-resistant products. and they seal these penetrations. They're put into your linear joint systems, and they're going to spread against fire and smoke. Again, the emphasis here is on a system. Firestop products are just one component of that system, and fire stopping is a pretty important part of the overall containment of fire and life safety in a building when that does happen. So Firestop systems are tested and listed in independent laboratories. In North America, UL and ULC, Intertech are probably the most common, but you'll also see listings for FM Global, Southwest Research Institute down in San Antonio. All of these agencies have their own published online listings. In the UK and other countries using British standards. Warrington Fire is well known, and there are many other relevant testing agencies depending on your location. The building codes are going to point to certain standards for fire stopping to be run at these independent third-party labs. The code doesn't say where the testing must happen, only that they must happen to a particular standard, and each of these labs can run to those respective test standards. So here are those test standards. You'll see there's an ASTM and a UL version of the code referenced. If you think about ASTM, it's going to give you base standards for F ratings, your fire ratings, and your T ratings, temperature ratings. And then the UL version typically builds on that, giving us optional tests like W ratings for water tightness and L rating for smoke leakage. And there's even some new M ratings for movement. But essentially, the main test penetration for penetrations is ASTM E814 and UL 1479. And then for fire-resistant joints, you see there it's ASTM E1966 and UL 2079. Finally, for curtain walls or the perimeter fire containment system, you see ASTM E2307 is the primary test standard, although E119 is allowed under certain code exceptions. There is no UL version in this case for these tests. If you're working in California, the CVC references the same test standards, but if you're in Canada, then the ULCS 115 applies. And if you're joining us from outside the United States, you might be using British standards, BS 476, Part 20, European norms, whatever it is your country or your local authority jurisdiction has adopted, always check there. But the basic principles of fire stopping are pretty much the same throughout the world. So what is a tested or listed system? Well, this is going to refer to a penetration or a joint assembly, again, which is rated per corresponding test standard that we just saw. Here on the top portion is a simple pipe penetration system. You'll see the written description on the left-hand side there. It'll help you out. All the elements of a fire stopping system, including the assembly to which it's installed, comprise a specific and inseparable engineered unit that must be utilized as such. Now, the specific elements for each design become integral to the listing. So again, the products don't have ratings. The systems have the ratings. So in this example here, we could see UL system CAJ 1240. It's going to describe all the elements of a metal pipe penetrating a concrete floor or wall. And then with the minimum amount of concrete or the CMU wall, that is going to give us that combination system. We'll see sometimes there'll be optional steel sleeves. Sometimes there's required sleeves. In this case, this one's optional. This system allows for up to a 30-inch diameter metallic pipe with annular space. That's the space between the outside periphery of the pipe and the inside periphery of the opening. Can be a maximum of 2 inches. With 0, we see that's actually point contact, meaning that this pipe can touch one part of the opening. There's going to be some mineral wool packed in there. And then finally, there's some Firestop sealant that's put in there on top side of the floor or on both sides of the wall. So now we can see that building codes require Firestop systems to be installed and tested in accordance with the applicable standards by qualified test labs. And these two sections of the IBC, the International Building Code, are examples. You can see through penetrations shall be protected by an approved through penetration Firestop system installed and tested in accordance with ASTM E814 and UL 1479. And then in joints, you can see it's installed in accordance with the manufacturer's installations and listing criteria. So simply put, install Firestop systems the way that they're tested or listed. Simple, right? Each system's like a set of installation instructions. But we can't test everything. There's no way to anticipate and test every single condition that's going to occur during the construction of a project or the life of a building. To put it nicely, unexpected things happen. Construction is a complex process that requires an incredible amount of coordination and communication. And let's face it, it's not perfect. We all know what happens during the renovation of old buildings when walls and ceilings are opened up or removed. There's always some surprises out there. And in addition, there's always new products, new materials are introduced every single year. There's new floor and wall assemblies that are always coming out. And construction methods change over time. Let's be honest. And codes and standards, they also change. There's a 3-year code cycle. So it goes on and on. So this is the reason why, engineering judgments exist. It's because field conditions differ from tested systems. There it is. So in this example, we have a hole that was cored in the wrong place. And so a second hole had to be drilled. Now the opening looks like that little figure 8. We've seen them out there plenty of times, and it may no longer meet the parameters of a tested system that's been chosen for that application because the annular space, again, that distance between the conduit and the edge of the opening, may exceed the maximum allowed by the system. So now what do? Well, first of all, you try to find yourself a tested system that does satisfy the field condition. You can look on UL's website called Product IQ, Intertech's directory of building products, or even manufacturers' websites. Or you can contact the Firestop manufacturer directly. In the case of that figure 8 example, there are systems available for larger openings. However, on almost every single job site, situations do occur during construction, which there are no tested systems available. So then you move on to step 2. If there's no tested systems for the condition, then either modify the condition, easier said than done a lot of times, or request an engineering judgment. When I say modify the condition, we mean something like construction related. Move a pipe, reduce the size of an opening, extend a wall, move a penetrating item. I mean, there's so many different things, but modifications aren't always possible and they're not typically practical. And then that's why we as manufacturers get called for engineering judgments to be requested. So there's several different definitions of engineering judgments. UL's definition, which can be found on their website, is broader than just Firestop systems. It addresses any fire-resistant design, assembly, or system. It simply states that an engineering judgment is a method or process used to resolve field needs when a tested design, system, or assembly is not available. It goes on to say that it should be done by someone knowledgeable, be acceptable to the local authority having jurisdiction, and be site-specific, which is an important part that we'll come back to later. The IFC, the International Firestop Council, also has a definition there. You'll see on the next slide. In fact, the IFC has a multiple-page guideline for engineering judgments, which is excellent. But first, if you're not familiar with this organization, IFC is a not-for-profit association for manufacturers, inspectors, and the users of fire protective materials and systems. It's a terrific source of information on all things fire stopping. So you can see here the IFC has a document available on their website called Recommended IFC Guidelines for Evaluating Firestop System Engineering Judgments. And within these guidelines, there's a definition of engineering judgments. To paraphrase it, it says, when field conditions differ from original design, purpose, alternative methods, sometimes referred to as engineering judgments or EJs. In Western Canada, EJs may commonly be known as TJs or technical judgments. And we'll get into the different names for that a little bit later. The IFC also has EJ guidelines specifically for your perimeter fire containment systems, that gap between the edge of slab and your exterior walls, air ducts, and grease ducts. However, for the purpose of this webinar, we're going to focus on fire stop systems, which include penetrations, joints, and perimeter fire containment systems. So I like to think of engineering judgments as just a fancy term for alternative design. EJs are a really quite simple concept, but it's important to understand how they're done and by whom, as well as the regulations that affect them, because they're an important part of fire stopping as well as life safety and liability. No one likes that word. But let's talk about the building codes for just a minute here. Although the codes, they do require fire stop systems to be tested in accordance with approved standards, alternative designs are allowed in IBC section 104.11. Codes are not designed to restrict the use of material, design, or method. However, alternatives must be approved by the building official. So although alternatives are discouraged in favor of tested systems, there are situations where they can't be avoided. Take CLT, or cross-laminated timber construction, for example. It's also, your heavy timber, your mass timber, and we'll see CLT construction is not allowed by the IBC for high-rise buildings. However, at the same time this was published, there were no listed fire stop systems available for CLT. So fire tests were in progress by manufacturers, but it's more challenging compared to using concrete, masonry, drywall due to obviously the combustible nature of wood. So UL developed a new category, which was published in October of 2022. And you'll find a limited number of fire stop systems using CLT walls and floors and on Intertek's website and UL. But by the end of this year and beyond, there's going to be plenty more. We actually have quite a few that have just dropped. So if you look at IBC section 104.11, it basically states that alternatives shall be approved where the building official finds that the proposed design is satisfactory and complies with the intent of the code, and that the material, method, or work offered is less than the equivalent of the prescribed, that is not less than the equivalent of the prescribed in the code. In other words, it has to be at least equal to the code, and it has to be approved by the building official. And in Canada, alternative solutions are also allowed by code, the National Building Code, NBC. Western Canada tends to lead the code enforcement, and if you're in Alberta, Calgary, Edmonton, and you're familiar with Standata, and it's a separate organization which publishes information bulletins, guidelines, and reports. And if you deal with British, European, or other codes, you're going to find that alternative solutions are allowed there as well. It's good practice to use tested or listed systems whenever possible, but also allow alternative designs when necessary under the guidelines approved by whatever your local authority having jurisdiction is. So let's get into who issues engineering judgments. Fire stop manufacturers typically issue them upon request, and there's typically no charge for this. It's part of the business. However, only qualified technical personnel should issue them. EJs may also be issued by architects, fire protection engineers, knowledgeable registered professional engineers, or some independent testing agencies that provide listings for services like fire stop systems like UL or Intertek. Some architects are also very knowledgeable about fire protection and design alternative various elements for construction on a pretty regular basis. But with Firestop, it's best to at least involve the manufacturer, because it's the manufacturer that knows how their products behave in a fire, as well as the full test assemblies, because let's face it, that's what we do. We conduct or witness fire tests all the time. So knowledge and experience are extremely important in order to design proper EJs with confidence. Issuing an EJ is the equivalent of stating that the design is expected to pass the stated rating if the test were performed. So salespeople, for example, they should never write EJs. Most fire stop manufacturers have plenty of qualified technical personnel who design EJs on a regular basis. So now let's talk about how they're designed. So here on the IFC guidelines, we mentioned them a little bit earlier. Most of the manufacturers follow them. There's a lot to know and understand in order to design a proper engineering judgment. For example, there's a big difference between a steel pipe and a plastic pipe. And in addition, PVC pipe burns differently than a polypropylene pipe. So electrical cables with copper behave differently than fiber optic cables. And a standard 2-hour gypsum wall performs differently than a shaft wall. So because of this, gypsum shaft walls are not symmetrical, and they have to be tested with each side exposed to the fire. So people who design EJs need to understand all of this and have to have the experience to design safe and effective systems. So what do engineering judgments look like? So we're going to show you some examples in just a moment, but they all look pretty similar to tested and listed systems. However, they should be clearly identified as engineering judgments. They're normally presented as one or more illustrations with a detailed description, just like a fire stop system, but illustrations are not required, and they may be in written form only. So there's no rule that says you have to have a drawing. Again, most do, but it's not a requirement. But EJ should also include a clear direction for the installation of the recommended system. What was it based off of? Cite the tested systems again. Identify the project name and location. It's very important. This has to be a site specific. It can't just be a general engineering judgment, as well as the company that it was issued to. So who's the responsible party? It needs to provide a complete description of the critical elements needed for the fire stop configuration. And it needs to show the date, the issue, and the signature and the person's name that issued this engineering judgment. So here we could see an example of an EJ that was done for a pretty large opening with multiple insulated pipes that was penetrating a 2-hour shaft wall. Now, generally, shaft walls shouldn't be penetrated, but sometimes it's necessary or it happens. So there's tested systems for insulated pipes through shaft walls, but they're pretty limited. In addition, these were steam pipes, and the insulation was up to 4 inches of fiberglass, which is unusually thick. So at the top, you can see a drawing, the fire rating, 2 hours in this case, and the engineering judgment number, which has been hidden for confidentiality. The main reason for this EJ was the insulation type and the thickness. Glass fiber insulation breaks down in a fiber, and if it's not fire stopped properly, it can allow the fire to spread through that wall. So fire stop collars were required around the pipe in this case, and these collars are going to expand into mess. When the fire hits it, it's going to close those gaps that are left by the consumed pipe insulation and any gypsum wall that maybe broke away. So in the middle section of engineering judgment has all the written descriptions, the wall assembly, what it's made out of, the penetrant packing material, any sealant, the steel collar plate, and in this case, the wrap strip with your steel collars. And then finally, the lower section looks a little bit like this, a title block. It's going to contain information including that project name and the location, the engineering judgment designer, the responsible party, usually a contractor or an architect, the signature, the date, and again, any referenced fire stop systems that that judgment was based off. So if you've ever wondered which applications have the most EJs, here's your answer. This chart's going to show the most common types of EJ requests done by STI in 2022. Other full-line suppliers of Firestop probably have a similar distribution, but of the thousands of EJs issued last year, about 59% were penetrations, 28% were joints, and 13% were curtain wall. But if you asked our engineering team about this, joints and curtain wall systems seem to take the most time. They are the most complex, the most difficult situations to deal with, and there's a lot of different variables when it comes to those joint systems. So how do you submit a request for an engineering judgment when you can't find a system? So most manufacturers are going to have some type of standard form, usually online. However, each company is different, so just ask what their process is. A standard form can act like a checklist. It could help you collect all of the relevant required information. In a minute, we'll show you what's required for each type of application, but in addition to information you can provide, such as plans, photos, sketches, notes, anything would help a great deal. Any information you could give to understand the situation better will provide an accurate EJ for you that's going to reflect your actual real-world field conditions. So this is just a snapshot of the beginning portion of an online EJ request form on STI's website. At the end of the presentation, we'll show you where you can actually find this. So what information do you need to request an engineering judgment? Well, first of all, EJs, again, have to have the name and the address of the project. I can't stress this enough. We can't just write a blanket engineering judgment. Remember, codes require EJs to be project specific as well. It can't be reused on different projects without submitting it for review in respect to that current project in question. A lot of times people try to get EJs written before a project even starts. That should never happen. All EJs also should note the responsible party. For example, if it's an architect, an engineer, or the contractor, even a building owner sometimes in the case of maintenance work or remodeling. Now, for penetrations, you're going to need to know the type, the thickness, and the fire rating of your wall or floor that you're penetrating. You need to know the penetrant type, the size, the type and size of a sleeve, if any, angular space, again, that distance. We need the minimums and the maximums and what that opening looks like. If it's a circle, we need to know it's a circle. If it's a square, we need to know it's a square. And then any special conditions, blank openings, no penetrating item. Maybe something was cored and you didn't need it. Maybe a pipe was taken out. If you only have one side access, this is helpful to know as well. Pipe couplings, if that's in the plane of the wall, any type of angled penetrant, equal F&T ratings required, anything that we need to know to help you along there. That's what we would need for penetrations. When we're dealing with joints, this is what we would need to know when you are Looking at joints, again, name and address of the project, responsible party. Then for joints specifically, we need to know the type of the joint. Is it a head of wall joint, a wall to wall joint, floor to wall, bottom of wall? What is the type and thickness of your different assemblies? What are they? You need to know what these adjacent assemblies are. Is it a brick wall going to a gypsum wall, or the underside of a floor? What is the joint width? And then again, any special conditions here with joints, typically they are designed to allow for movement. So what is the movement capability of the joint? Access to one side, again, if you only have one side access, sometimes the answer here is a stuff spray kind of thing. Any kind of steel support angles on the top of a block wall that might be in the way. If there's fireproofing on a beam that might be penetrating somewhere, all of this we need to know. And then finally, for your perimeter fire containment systems, EJs, we always start with the exterior wall. I mean, one of the assemblies here is not rated, and that's typically that wall that's made up of things like aluminum that melts and glass that breaks. So what is that wall made out of? We need to know, is it precast, GFRC? What type of floor are we dealing with? And the thickness of that floor. What is the fire rating of the floor? Typically, you have 2-hour, but sometimes you have a 1-hour floor. Sometimes you have a 3-hour floor. So need to know the rating of the floor. Joint width, obviously, this is going to factor into how we're going to deal with that little gap there, or maybe not so little. Any sill heights, special conditions, again, your movement here, wind sway, dynamic, static. Sometimes your curtain walls can be a static system. Do you have anchors that are mounted on the top? Are they in the middle? Are they bottom side anchors, steel back pans? Again, anything that you could tell us about that panel and any conditions of the floors will help us along the way. So how long does it take to get an EJ? Well, this is going to depend on a lot of different factors, but when you're in the middle of a project, EJs can cause construction delays that, if not handled efficiently, really could put a damper on the profitability of your job. So we understand as manufacturers that turnaround time is very critical, but it's always going to depend on having the most clear and complete information. This is the number one reason for delays. The complexity of the application is always going to factor in there. The efficiency of your manufacturer's process and their technical personnel, the volume of EJs at the time of request, any number of changes, corrections going back and forth, and any number of factors could really take some time there. But STI, we've set the bar pretty high in the industry. We typically turn around EJs in 24 hours or less. In fact, there's many that turn around in just 2 or 3 or even 4 hours. However, there's times of years that are busier than others. For example, March and April tend to have a pretty high demand for EJs. So when you make a request, try to put yourself in the shoes of the other person who's designing it. If they don't have all of the information, they're not on site, so they don't have that advantage. So they're going to rely entirely on the information that you provide. So again, use details, photos worth 1,000 words, right? Notes, hand sketches, very helpful in understanding your actual field conditions. And this is critical in order to design an EJ that meets your needs and satisfies the code. So do EJs need to be stamped by an engineer? This is a great question. And the answer is generally no, but it depends entirely on the jurisdiction. Some AHJs do require a licensed engineer, and in some cases, a fire protection engineer, to review and stamp your EJs. On this slide, there are a few examples of this, but again, this is not an extensive list. Requiring EJ stamps is a strong deterrent against the use of them due to the time and the cost. And if you ever wonder why jurisdictions require this, the reasons are going to vary, but the predominant theory is twofold. The first is to discourage the use of EJs, simply, and two is the lack of trust in those who are providing them. Now, that doesn't mean that they don't trust manufacturers in general, but it only takes one bad apple to spoil the bunch. So in other words, it only takes one person who may have been not qualified at some point in time to issue an EJ that now this just bad spiral, bad loop. So here you could see some of those jurisdictions, and the cost of getting EJs are going to be, they're going to vary depending on the engineering firm as well as the complexity of the application. In our experience, we've seen engineering judgments stamps for around $600 to $1,000, but I've seen top $1,500. An example, imagine a large project where you have 100 EJs that cost at least, it could be $60,000 or more for the review of just stamping those EJs. So why don't manufacturers just stamp them? Well, the reason is the manufacturer is not considered independent third party. So when needed, we can refer you to some engineers who provide the review and the stamping that are licensed in all 50 states. Some of them are licensed internationally as well. So if you need that, just reach out. There are some AHJs who do not allow EJs for new construction. Again, I mentioned this. Sometimes we're asked to do an EJ before building even starts. So this isn't going to happen in certain jurisdictions, at least during the design and the permitting phase. So now, contrary to what you may think, most building officials are pretty reasonable. So we've all heard some stories who maybe came across some that weren't, but in my experience, most are pretty agreeable to be reasonable solutions when problems occur during construction. But for new construction, one reason some jurisdictions stop accepting EJs is that too many plans were being submitted for new buildings with dozens of EJs before construction even started. So this goes well beyond Firestop, and they just grew tired of this, and who can blame them? Their job is to enforce the code, and in many cases, the code was being ignored and substituted with less expensive alternatives as part of the original design. So from that point of view, it's easy to understand why a building official might have that position. EJs are meant for situations where there's no tested assemblies, and theoretically, that should only occur during construction, where all kinds of unexpected things happen. But nothing's that black and white, and every project and every jurisdiction is different. So now let's take a look at some real world life examples of recent EJs. So this was an example of an existing prison where the AHJ was very strict on code enforcement. The wall was a shaft wall, so there was only access from one side, and the joint was concealed by a continuous steel angle and fireproofing. You'll see that better in the next slide, but you might want to look at that and think there's enough for a 2-hour rating, but there's no tested system for it. And the area above the wall was concealed. So no one really knew what was behind that angle. So this is a good example of good notes and a clear drawing, and it's very easy to understand the basic situation here. Here's some additional information that was provided. It's going to show that steel angle at the top of the wall. They were installed for structural and connection and inmate security. It's a pretty dark photo, but if you look closely, you'll get a sense of the condition that they were facing. There's some missing fireproofing, as noted there. The head of wall joint is also covered with spray-applied fireproofing. So the goal was to provide a 2-hour continuity of the wall all the way up to the underside of the roof. So the solution in this case, which was a collaborative effort with the architect and the contractor, was a gypsum shaft wall construction like a soffit with fireproofing where it meets both the wall and the underside of the roof. The steel angles were not touched. So here it is in a little bit more detail. You can see that there was a sandwich type of fire stop system. Again, which I mentioned a little bit earlier, your stuff spray. You had some mineral wool backing and fire stop spray above your shaft liner. And then you had some fire stop sealant down there at the bottom there. So this system took some back and forth to get all the details correct, to satisfy the fire marshal and to be confident that it could be constructed properly. So here's another example. This was a relatively simple condition once you understand it. You're looking at an elevation view of an exterior window wall with GFRC spandrel panels, and the gap is between the edge of slab and the wall. You had about 8 inches wide, and it was filled with fire safing or mineral wool. Looks pretty good on the surface, but there were 2 issues. First, there's a metal panel fastened to the inside face of the GFRC panel. It's filled with mineral wool, but that's not part of any tested system. And number 2, although there's fire safing in the joint between the edge of slab and the metal panel, the density and the compression were not called out, and there's no fire stop sealant or spray for your smoke seal, as well as fire and hose stream resistance, which is part of the test. So the solution in this case was essentially to add a Firestop spray over the fire safing and call out the mineral wool density and compression. So the next slide will show us that in a little bit more detail. We see here there was a minimum depth of 4 inches of mineral wool with a 4-pound density, and it was required in the joint to be compressed at 33% between the edge of slab and that metal panel, and then sealed on the top with a Firestop spray. Here's our third example. This is a membrane penetration. In this situation, there's a 2-inch diameter steel conduit penetrating one side of an existing wall made of lath and plaster. The wall consisted of 7/8 inches plaster on metal lath on both sides for a total wall thickness of 5 inches. The building was an older hospital. It was built, I believe, in the 1950s, just before drywall started replacing lath and plaster as a quicker and easier installation option. And since modern-day Firestop testing didn't begin until the mid-1980s, there aren't any tested or listed Firestop systems using plaster walls. However, that doesn't mean that plaster doesn't have a fire resistance, because it does. In fact, the IBC has a table of the rated fire resistance of various walls and partitions, including plaster. So if you're interested in learning more about that, refer to IBC section 719, 720, and 721. So the person who submitted this request cited that the code, which supported a 1-hour fire rating for this type of wall construction, and based on our experience and similar tested with drywall, we were able to provide an engineering judgment pretty easily. It was a simple solution. I know the drawing here looks opposite, but this condition turned out to be really easy, just using Firestop sealant around your conduit. Simple. So the last example here, this building had some curtain wall conditions that did not conform to any existing system due to angled walls and some special corner designs, and code enforcement on this was very strict. In fact, the building official was not accepting any engineering judgments, but we tried anyway because we were confident we could provide a design that would pass 2 hours and convince the building official that it would perform well. Here's an elevation or a side view of that angled wall passing by a concrete floor. And here's a plan view looking down at a typical floor, showing a step back corner. The darker shade part is the joint between the floor and your curtain wall. There were also 2 different types of glazing systems planned for this project. You can see those here. So this is a draft of a solution. At this point, we were still collecting information from the architect and the general contractor and going back and forth on a proposed design. You can see some of the redlining on the drawing. This was not a final design yet. We felt the condition was reasonably similar to other tests that had been done. So as a group, between the GC, the architect, curtain wall manufacturer, and STI, we proposed an EJ that made our case to the building official to avoid having to do a test, but to no avail. The request was denied. So there was no choice but to do an actual fire test because the project was too far along to change the design of the curtain wall. So we designed a test and moved forward. This was the curtain wall construction detail. You can see the step back corner at the top and the angled wall there in the larger drawing. The testing curtain wall is testing curtain wall is a long and expensive process to complete. So this part of the project was delayed for months while the test was being done. So if you've never seen a curtain wall test, this is what it looks like. It's a 2-story apparatus with 2 burners. The interior burners lit first, followed by the exterior burner after about 5 minutes. In this case, the goal was a 2-hour fire rating, but we let it go much longer to just take in some additional data and observation. It was a very successful test. And in the end, a new UL listing was published, as you can see here. It might never be used again because it was a very specific to this project. But if some similar condition appears on a future project, it's going to be a good reference for us. So please understand, this was a rare case in which a test had to be done. We most certainly can't test every situation that comes up. The cost and time required are strictly prohibitive. So nothing would ever get built if we had to do that. So one last point before we want to test your knowledge and then open it up for some Q&A. There's been some recent trend from code enforcement officials to move away from EJs and to accept only third-party certified systems because they are sometimes issued by untrained and unqualified personnel out there. They have a reduced confidence that the code enforcement officials just don't want engineering judgments. So up until recently, there's been no oversight on the EJ process. So each manufacturer is responsible for their own process, and that's not going to change. However, UL Solutions, as it's known now, together with manufacturers and others, created the Technical Evaluation Developer Program to take a closer look at those who issue engineering judgments, or what they're calling technical evaluations. So the goal of this program is to create more validity and acceptance of engineering judgments throughout the industry because they are a necessary part of fire stopping. So if you've been in construction for more than a day, you realize how buildings get built often varies from the intended design. And that's because there's a disconnect between what's acceptable per codes and standards. AHJs may not accept EJs because they want certified or tested solutions. But because we know things don't get built exactly the way they were designed, sometimes we need to find the best possible solution to improve the current state of affairs when issuing or even accepting EJs. So a structured framework and a defined qualification program were going to provide some ease for acceptance. It's going to ultimately reduce the number of low quality technical evaluations in the market, as well as increase testing and certification. So to be accepted into the program, organizations who issue EJs will need to prove that they have a quality management system similar to UL qualified fire stop contractor programs. The audits are going to be conducted by UL's fire barrier field engineering team. They also focus on adherence to the program. This is not a technical audit of the technical evaluations themselves, but rather it's an audit of the process. So non-compliant requires follow-up and may require additional auditing. And then testing, this is where rubber meets the road. This is a mandatory part of the program. The number of tests are going to vary depending on the number of technical evaluations issued, and it's going to be spread over a variety of industry segments, penetrations, joints, and your fire containment systems. So participants are also required to review their own work on a regular basis to follow up on a formal approval through UL. In other words, EJs are repeated and encouraged. The ones that are repeated are encouraged to be tested. The goal is to reduce technical evaluations wherever possible. But the main point here is that design professionals should be aware of this because you have the ability to include in your language, in your specifications, that you would only allow TEs, technical evaluations, or EJs, engineering judgments, on your projects issued by members of this new UL program. That would ensure that you have a reputable, certified developer and can help make AHJs aware of the existence of this new program. So at STI, we're proud to say that we are certified, or the people that write engineering judgments are certified under this UL program. And I believe our major competitors are too, or they're right behind us there, but definitely something you should all be aware of. All right, now we're going to get in to test your knowledge to see how well your listening skills were. Anna, are you ready to launch that poll? All right. So I'll read through these questions here and you answer the questions as we go along, and then we'll get into some questions from me after. So number one, fire stop systems are required by building codes and must be tested and rated in accordance with approved test standards. Is that true or false? Again, we're talking about fire stop systems now. Number two, which one of the following statements is not true about engineering judgments? Are they a method or process used to resolve field needs when a tested design, system, or assembly is not available? Are they a drawing and description designed by a fire stop salesperson? Are they another term for an alternative design? Or must they be approved by the building official? Again, which statement is not true about engineering judgments? All right, moving along to number three. Who issues engineering judgments? Is that primarily manufacturers? Is it knowledgeable, registered professional engineers? Is it qualified personnel approved by the building official? Or would that be all of the above? Again, who can issue an engineering judgment? All right, number four. Do engineering judgments need to be stamped by a licensed fire protection engineer? Is that a true or false statement, or does it depend on the jurisdiction? Wink, wink. All right. And do engineering judgments need to be stamped? All right. And finally, number 5, if it makes an application easier or cheaper, engineering judgments can be used even when a tested system is available. Is that a true or false statement? Come on, people. I know you know this. All right. We'll give you another moment to answer. All right. And Anna, you can close it off. Let's see how everybody did here. All right. And the answers are up on your screen. Number 1, fire stop systems are required. True. That is a true statement. They need to be tested in accordance with approved test standards. 5% of you got that one wrong. Maybe you thought we were talking about engineering judgments, but no, your fire stop systems have to be tested. Number 2, which of the following statements is not true about engineering judgments? 82% of you got that one right. It is not a drawing or description designed by a fire stop salesperson. Don't let them do it. Number 3, who issues engineering judgments? So 77% of you guessed all the above. You were right. The other 23% of you were not wrong. But the best answer in this case was all the above. Again, manufacturers, engineers, anybody qualified by the building official at this point. Number 4, do engineering judgments need to be stamped by a licensed fire protection engineer? 84% of you got that one right. It does depend on the jurisdiction. And then finally, if it makes an application easier or cheaper, engineering judgments can be used even when a tested available system is there. That is a false statement. You cannot do that just because it's cheaper. So great job. We're going to give 100% to the group as a whole. So now we're going to get into a couple of questions for our presenter guy here. It looks like Keith has been hitting up the questions. So while I have you here, if you could leave some feedback for us on LinkedIn, we love when you do that. We always do that. We have some swag bags. So we always pick a winner for the best comment over there. So while I'm reviewing some of these questions, maybe if you could head over to LinkedIn, let us know how we did. And we have a couple questions that look like they're popping up here. Keith wants me to answer this one. What kind of engineering when engineer can stamp the EJ? Does the engineer need to be a fire stopping professional? So we covered that a little bit earlier. It could be a PE, it could be a fire protection engineer. Sometimes the jurisdiction will require it to be an actual fire protection engineer. Sometimes it could just be a PE. Again, a lot of times it's going to depend on the jurisdiction itself, just like some jurisdictions don't require it at all. Some jurisdictions are going to require the engineer have a certain level of engineering knowledge there. So hopefully that answered that for you. Is there a maximum percentage number of EJs permitted on a project? If not, then what is a normal amount of EJs for a typical project? Wow, there's nothing typical about this question. I don't believe that there is a maximum number allowed. Again, there are some projects where we've seen hundreds of engineering judgments issued because things were not built normally. So the normal amount of EJs for a project, that's going to depend. I mean, you have so many different types, wood frame, high-rise buildings. So again, just try to construct it as proper, and we may not need those EJs. So I know it's not a great answer for you, Francois, but there's nothing typical about this. This is why it's alternative means and methods. But any other questions? No? All right. Well, if wouldn't the local IBC, ICC, AHJ requirement supersede all EJs? Not really sure what that question means, but yes, again, it's a lot of it's going to come down to your local authority having jurisdiction. So the code does allow it, alternative means and methods. We showed you a few examples of where that shows in the code. So yes, the AHJ would supersede anything that, the IBC says you can and can't do, which is why we actually had to do that testing on that curtain wall panel there. So sometimes, I've heard that building something to code is the least safe way to build it legally. So if AHJ wants something to be built something a little bit safer, they certainly have the ability to ask for that. All right. Are there any charges from STI for EJs without an engineering stamp? So no, there are no charges for us to do an engineering judgment for you. The stamping, the cost comes with the stamping of the engineering judgment. And again, sometimes depending on your jurisdiction, you may not have to have it stamped. So you could potentially have no charge for an EJ. Let's see, this is a long one. An existing wall condition does not readily conform to a UL system. Can engineering judgments be issued for an existing wall construction for a rating? For example, speed tile behind the face brick in an existing building. So this is, again, if we don't have a penetrating item or some type of fire stopping issue there, then we might not be the one to comment on the wall construction. So you may need to go to the architect or engineer, or to see who is the manufacturer, whatever materials were being used within the construction of the wall. But if there is a penetrating item, then we'll do our best to take a look at that wall construction and figure out what we can from an engineering standpoint and issue a judgment, or hopefully provide you with a tested system for that. All right. Does EJ have teams working with AHJs to move to accepting EJs where they are currently not accepting them? So we do not personally have a team that's going out there. Obviously, we do things like this to make AHJs aware of the fact that there are programs like UL's technical evaluation program there, so that you know that there are manufacturers that participate in programs that have some oversight. So while we don't have a team that go out there, we do things like this to make the industry aware that there are alternative means and methods that are necessary sometimes, and we do have a team of people that are able to get that paperwork for you. So, all right. Looks like that's all the questions. If any more pops up, we'll answer them a little bit offline. But while we have a few minutes here, let's just roll through here just to let you know that this was brought to you by STI. Firestopping is our only business, and we're here to provide innovative, cost-effective fire stop, smoke, and sound solutions throughout the world. You can see we're globally based in beautiful Somerville, New Jersey, about an hour west of New York City, but we do have offices and warehouses worldwide to serve you wherever you may be. So here's where we're going to need you to grab your smartphone or type this or earmark this website, Access STI. This is where you're going to need to create an account for Access STI if you don't already have one. Once you create this, it's free to do so. It takes about 2 minutes. You'll get a verification email. Once you have your Access STI account, in your dashboard, you'll see something for Firestop University. This is where you will find the recording of today's presentation along with your certificate of completion. Again, give us a few days to get that up there, but while you're here now, create yourself an Access STI account. Again, it takes just a few minutes and there's no cost to do so. If you're out in the field and you're going to be needing to look up UL systems and different types of fire stop systems, I highly recommend you download our System Search and Submittal Builder application. This is great when you don't have Wi-Fi access. It works without that on both Apple and Android devices, and we have over 1,500 systems. So, but when you find that one of those 1,500 systems doesn't work for you and you need an engineering judgment, this is the support team that you'd be calling on from 7 a.m. to 7 p.m. Monday through Friday. They are available to you either on chat, on that app, on the website, on your phone. You can just start talking to them, take a picture of a condition on a job site. It's great, easy to use, no charge for this. You can call them, you can email them. They'll do, again, engineering judgments, any types of lead documentation, letters for AHJs. Get in touch, their services, all free of charge. For any designers out there, we have guide specifications for all of our products. They are easily downloadable Word documents that you can cut and paste into your spec to make sure that you have the most updated specification. We can also do a complimentary spec review for you. If you're in the design aspect of things, we offer the Revit families for architects and engineers to import into your building models. We have BIM objects of all of our products, and we also have a cool tool called Firestop Clash Management. It's a plugin for Revit. It uses clash detection, and it's going to find where your penetrating items are meeting your fire rated barriers and actually select the appropriate systems for you. So it's a great project program to use. And then one more we want to tell you about is Firestop Locator. This is for construction and documentation of all of your fire stopping systems, your joint systems, your penetrations. It's great if you're an architect, if you're an installer, an inspector. It just makes everything a lot easier when it comes to inspection. So we have barrier management programs. So if you're getting ready to launch a new project, reach out to your local territory manager. At STI, we can coordinate your subcontractors if you choose not to use a specialty fire stop contractor, which you probably should. But if not, we can coordinate either analog, old school binders, or even digital. This barrier management program, it gets all your MEPs and drywall contractors, everybody on the same page. It helps for standardization, it allows for better pricing, better training, just more support on the job there. So reach out if we can help coordinate that job for you. And then, as I mentioned, getting into Access STI, once you're in that dashboard, click on Firestop University. You'll see this page. It looks a little like that. We have a bunch of different courses that are available as playback from some of the webinars that we've had over time there. So if you need a lot of credits, I know we're at the end of the year. We have plenty of credits for you. So that's over there at the Firestop University. And then finally, as we know, we have the Credly badges coming. Anna told us all about these a little bit earlier. Anna, is there anything else you want to tell us about?
Just wanted to remind everyone that we will be reporting AIA credits for those who gave us their member number and attended at least 75% of this live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. Lastly, you will all receive an email within 5 business days when the recording and certificates are ready. If you have not created an Access STI account yet, please make sure to use the same email address you use to register for today's webinar when creating your Access STI account. That's all I got, John.
All right. Thanks, Anna. And thank you all for tuning in today. And Keith, you don't have to unmute if you don't want to and save your voice, but thanks for helping out on the Q&A there. And thanks for putting this presentation together. And I hope I didn't bore you all to death. So we'll see you next week. Thanks so much. Take care.
Bye, everyone.